Greetings, soccer team. Glad you're out there. Hopefully you're celebrating a win by the time you watch this, and everybody's going to just be able to understand everything when we go over it, but just we love you all, and we're hoping you get back soon and have some good stories of victories. Moving right along, though, we're going to take a look today about more proofs, which we need to do, because we need to be able to prove lines are parallel, so that once you know lines are parallel, then you can do all those other things and find all the other angles because you already know they're parallel. So all those theorems that we talked about yesterday and the day before about saying if the lines are parallel, then certain angles are congruent, they can all be reversed, and we call those converses. They can all be conversed, I guess we'll call them. You would take a converse of it and switch it around so that if the corresponding angles are congruent, then that's enough to tell us that the lines are parallel. So it's taking and it's reversing the whole thing. The converse of the alternate exterior angle theorem. If the alternate exteriors are congruent, then the lines are parallel. So you can see how it's the hypothesis and the conclusion have switched. But they all actually do follow along. We know that converses don't always have to be true if an original statement is, but in these cases, these converses all do turn out to be true. So if you're proving that lines are parallel, you're going to be using the converses. If you're trying to show that you have certain angle measures, that's when you're going to be using the original theorems and postulates. So just be careful of that. So the other converses go with the other ones. That if the alternate interior angles are congruent, then the lines are parallel. And if the consecutive interior angles are supplementary, then the lines are parallel. So all these different things that we talked about before, we're going to be able to use in those situations. Also, we have this perpendicular transversal. So if two coplanar lines are perpendicular to the same transversal, then they're parallel. It almost sounds kind of like transitive property for this one, but it's not, because for this one, and let me just sketch in a little quick picture so that you can hopefully understand. Two coplanar lines are perpendicular to the same transversal. So we've got, here I'm going to draw the transversal first. And if you've got two coplanar lines that are perpendicular to that, so you'd have one that was perpendicular, and then a second one that's also perpendicular. Okay, then that should make sense that these two would have to be parallel to each other. Okay, so that's what this one is. This one's actually saying. So all of the conclusions for these converses are, the result is then they are parallel. So if you were using them in a proof, your statement that would have to go with it would have to be something with parallel lines, okay, for the converses. However, what we're going to start with is trying to use a little bit of algebra integration into this, and we're going to find x so that a and b are parallel. So if we're trying to make sure that a and b are parallel, what has to be true about these two angles? Yes? Good. They have to equal each other. They're corresponding angles, so we're kind of going for the converse of the corresponding angles theorem, but even if you're not thinking that through exactly that way, these two angles for parallelism would have to end up being equal to each other. So I want to do that algebra because one of the things we need to do is review our algebra a little bit so it works better on the paint. So I've got this pulled up here. Cece said that they have to be equal to each other. That was very good. So 3x plus 15 has to equal 5x minus 13. And for our algebra review skills, you have to make sure that you have x only on one side. So how do we do that? Subtract 3x is the easiest, sure. Subtract 3x. So we end up with 2x minus 13. And I know it's like all of you are all over the map as far as what you remember from algebra. So if I over-explain, just please forgive me and realize that it's because somebody needs it. 15 equals 2x minus 13. And so I need to then do what? Plus 13, add 13 to both sides. So 2x equals 28. So that would mean that x has to equal 14. Good. So going through, working carefully, starting with the fact that they're equal to each other, working through your algebra that we're doing a good job to review. We don't want to forget the algebra in our geometry year, but we're just doing less of it. So back over here. So we have x equals 14. All it asked you to do was find x. So you wouldn't necessarily have to plug it back in. But if they asked you to find the angle, then you'd plug it back in and you'd get the angles that go with it. And so what the other thing that we need to do is we need to be able to do proofs with them. Okay, so if you turn your paper over, I have a proof, and we're going to go through finding reasons. But I want you to understand what's happening in it as well. So you've got your proof that's sitting there. Once again, I pre-copied it over here so I can write more easily. We're starting off being given that angle 1 and 2 are supplementary. Okay. Notice that there's not really a special name for them. Some of you might be thinking I would want to make up a special name for them, but we don't have a special name for them. But what we can do is we can go through and work our way from this to knowing that L and M are parallel. So let's go through these steps just one at a time, and hopefully it's going to start clicking in as far as, well, wait, yes, that makes sense. And as long as each step makes sense and leads you towards the conclusion, then that's really what proofs are all about. So who can tell me why angle 1 and angle 2 are supplementary? What's our reason for that? Well, that is what our conclusion will be on step 2, yes. And that's why we have step 2, so I'm glad that you noticed that. But the first one is given. Because it's in our given information. So you're always asking yourself the question, when you've put something down, how did I get here? Or you're trying to figure out logically what the next step is. You're like, okay, what do I know from what's already here or what's in the picture? And then you're answering the question, how did I get here? And that's your reasoning. So angle 1 and angle 2 are supplementary. So measure of angle 1 plus measure of angle 2 equals 180. Does anybody know how did we know that? Yep. Well, that would be right if they were consecutive interior angles, but they're not. They're actually, why are they not consecutive interior angles? Yes. Actually, both of them are not interior. Okay, so yeah, see, they said one of them is not interior, but they're both not. But they kind of look like it, don't they? Because they're on the same side of the transversal. Just so we can get that cleared up as far as which ones are the consecutive interior angles. 4 and 3 are consecutive interior. So I want that to be kind of rattling around in the back of your mind. Okay, so so that we can think about that later on. But these are not, but just looking at step 1, you can go to step 2, because we said that angle 1 and angle 2 are supplementary. And so can anybody explain then how that's 180? Can somebody tell me what the word supplementary means? 180. Two angles, when you add them together, equal 180. Sure. And that's exactly what's said here. You've got the two angles, and they add up to 180. So really, when all you're doing is explaining what a word means, so this is the definition of supplementary. So really, a lot of times there'll be where you come to the next step, and the only thing that really happened is you took the word and you wrote down what it meant. And that's your clue that, wow, that was a definition. There's no other reason, just because that's what that means. Okay. Now we've got this step here, because it was already pointed out that these are consecutive interior angles, and we want to keep that in our mind because we know stuff about consecutive interior angles. That is one of our theorems. So kind of along that line, this step is actually pulling those two angles into the problem, saying that angle 2 is congruent to angle 3 and angle 1 is congruent to angle 4. But tell me, please, why those are congruent? Because they're vertical angles. So that one is the vertical angles theorem. Okay, and really your reasons, they're answering the question because. So why is this true? Because they're vertical angles theorem. A lot of times the reasons are what they sound like. If you're explaining it to somebody in your head, and if you're ever at a loss as far as the name of something and you write down the description of what it is, you still get credit for that. So for example, if he didn't say the vertical angles theorem and he said because vertical angles are congruent, that's okay also. All right, because you're actually saying what the theorem was, and that's okay also, and you get full credit for that. So now angle 1 is congruent to angle 3. Angle 2 is congruent to angle 3. Angle 1 is congruent to angle 4. I want to deal with the numbers, so we turn that into angle 2 equals angle 3 and angle 1 equals angle 4. And what are we thinking for that one? We've used this one actually quite a bit. Definition of congruent angles, absolutely. Because you're taking your congruent notation and turning it into an equals. So the definition of, and we can use symbols if you want, congruent angles, if you don't really feel like writing all that out. Definition of congruent angles. And then we knew that angle 1 plus angle 2 equaled 180. Then we said that angle 2 is the same as angle 3, and angle 1 is the same as angle 4. And that turned it into angle 3 plus angle 4 equals 180. So what happened? What word would we use to describe what we did? Yeah. It's only transitivity if it's not happening in the middle of a problem. But what's the other one that's kind of like transitive, but not really, but sometimes I said you can use it interchangeably, but substitution, yeah. So whenever you're having something come in and it goes in the middle, rather than just two things equal the same thing so they equal each other, it has to be substitution. If you are ever in a case where you are trying to guess, substitution, and you're saying, gee, I don't really know which one to pick. Is it substitution? Is it transitive? I'll tell you right now that your guess is more likely to be substitution if there's an equals. And it's more likely to be, and it can't be substitution if it's a congruent. So you can kind of get around that by kind of making yourself a note that if I have an equals, even if it is transitive and you put down substitution, you're still right. But if you're thinking, gee, that looks like substitution, but you see a congruent sign, then write down transitive. Okay, because that there is no substitution property of congruence, just equality. So there's a little hint for you. So we've substituted in angle 3 plus angle 4 equals 180. And then we have our step 6 that says angle 3 and angle 4 are supplementary. Angle 3 plus angle 4 is 180. So angle 3 and angle 4 are supplementary. We've actually used this reason already in this proof. How do we get from here to here? What do you think? Go. Well, first of all, vertical angles, are 3 and 4 vertical angles? No. So not vertical angles theorem. So make sure when you guess, make sure to think through which one it could possibly be. Yes. Good, absolutely. Definition of supplementary. Definitions can usually go both ways, like supplementary turning into the 180 notation or 180 into the supplementary notation. That's the other thing about definitions, is definitions can go either direction. Oh, and a quick word on number 5 with the substitution. When you're writing out substitution, make sure you write enough of the word, even people that like to abbreviate, make sure you write enough of the word to differentiate between whether you mean subtraction or substitution. If you just say sub, it could be either. So don't make me guess which one you mean. So when you mean substitution, write substitution. So definition is supplementary because 180 really means that they're just supplementary. So then finally, our final conclusion is that means that L is parallel to M. Okay, so you have, I believe, 5 different converses. Which one of them tells you that if 3 and 4 are supplementary, then L is parallel to M? Yes. Are 3 and 4 alternate exteriors, though? Because we're coming right off of 3 and 4. 3 and 4, we have some exterior angles, but we don't have the alternate exterior ones even labeled. But what is the name of those 3 and 4? Anybody remember? Go, Cece. Good. They're consecutive interior angles. So that would be the consecutive interior angles converse, or the converse of the, you could say consecutive interior angles converse, or you could say the converse of the consecutive interior angles theorem. So we're just going to write the converse. You do have to have the word converse in it because the conclusion was parallel lines of consecutive interior angles theorem. Or if you just wrote consecutive interior angles converse, I would also count that as 100% correct. So once again, when a proof is done, you're trying to get a logical conclusion where you always have a good reason for everything that you say that leads you from the initial premise or the initial hypothesis to the final conclusion, and you're trying to do it in as few steps as possible without anything that you don't need. Okay, so it's kind of a wrestling back and forth thing. Okay, again, where we are right now is that I'm mostly expecting you to be able to give reasons, not the statements and the reasons, although we did have that bonus on your test where if you were able to do that, and a couple of you were, so I'm impressed that we're getting there. And there's a couple people who are already getting that logic path and being able to go on their own from a hypothesis down to a conclusion with all of the correct. So that's our goal, is to get to where you can do some proofs on your own. All right, let's get back to this. So we just did that one. And what we need to do is we need to look at another property. Okay, transitive property we already have dealt with the equals, and already have dealt with a congruence. So here we have with parallel, we also have the whole thing happening. Okay, so if L is parallel to M and N is parallel to L, so they're both, they're all three parallel to each other, basically. As long as L is parallel to M and M is parallel to N, then L has to be parallel to N. This works in one plane. It also works if you go out of the plane. So if I wish I could pick this piece up and I could just pull that line. I'll make a new line. If I could pull that line like right out into the third dimension, that would be fantastic. And we could show that that actually works even if they're not all in the same plane. I think I'm going to go out on a limb here and try and draw that so that you can see. So if I were to draw a triangle and another triangle that matched it, and then I were to connect the corners, I'm going to get a prism, we know that, but if I were to connect the corners, and I said that if those two are parallel, correct? L is parallel to M. Okay, so if those two are parallel to each other, and then we put in another one, and L is parallel to N, and those two are parallel, so these two are parallel and those two are parallel, then M would have to be parallel as well, even if you do bring it out into the third dimension. So you don't have to necessarily sketch that. If I was doing it and not putting it online, I would be holding up those poles. Okay, you know my favorite poles that I use for this, that you'd have parallel and then you'd have a third one parallel. And it doesn't have to be in the same plane for that to work. So if two are parallel to the same one, they have to be parallel to each other, whether they're coplanar or whether they're outside of the plane. So when you have a more complicated drawing, we want to talk about which lines can be proved parallel with each statement. You have these on the blank sheet that you've got in front of you, but which lines can be proved parallel with each statement. So if angle 1 is congruent to angle 3, you have to identify, which lines use the transversal that's attached to angle 1 and angle 3. So if angle 1 is congruent to angle 3, who can tell me which lines then would have to be parallel? B and C, absolutely. B and C. Because this part really has nothing to do with it. Angle 1 and angle 3 are congruent to each other. So that means that the two lines that are right along that transversal are also congruent, parallel. And what is the name of these angles, their relationship? 1 and 3 would be called, go ahead. If we're just looking at that one, there is one of them that's exterior, but if we block this out for a minute, this one's exterior, this one's interior. If you kind of turn your head sideways and you block out part of it, what do you think? Corresponding. They are corresponding angles. So this is the corresponding angles converse, or converse of the corresponding angles. I'm just going to keep this one over to the side so I can pull up. And you can even take a piece of paper like that and cover up the part that's irrelevant to help you figure things out, and that might help you. So for angle 1, if angle 1 is congruent to angle 15, angle 1 is congruent to angle 15, which two lines does that show are parallel? A and D. Good. And somebody different, A and D are parallel because 1 and 15 are called what kind of angles? Yep. No? What's the name of angle 1 and angle 15? I want to call on you, but I also want somebody else to jump in if they can. So if you're looking at your notes, angle 1 and angle 15. First of all, you should be figuring out, are they interior or are they exterior? So I'll just ask, which are they? They're exterior. So they're both exterior and they're on opposite sides of the transversal, so their name would be alternate exterior. So it's our alternate exterior angle converse. Good. Do make sure that you're studying these angle names, because really once you know the names of the angles, then understanding what happens with the proofs becomes infinitely easier. So let's look at angle 6 and angle 12. So knowing that angle 6 is congruent to angle 12 tells me which two lines are parallel. How about which two lines are parallel? Is it going to be B and C, or is it going to be A and D because of 6 and 12? Everybody, let's get everybody involved in this, because I've only got a couple people who are volunteering, but I think more people. Okay, if you think it's A and D, I want you to put a 1. And if you think it's B and C, A and D, I want you to put up a 1 with your fingers. And if you think it is B and C, I want you to put up a 2 with your fingers so that you can let me know what you think. Okay, good. I'm seeing that more people knew than were actually willing to take a chance and say it out loud. It is A and D. Good job. So A and D are parallel because of 6 and 12. And then what would be the name of those angles so we can identify which converse it is? I think somebody, alternate interior, yes. So this is the alternate interior angle converse, tells us that A is parallel to D. Okay, once again, 12 and 10. 12 and 10. I want you to show me by show of hands. 1 for A parallel D, 2 for B parallel C. Show me which ones. Okay, scanning around. Okay, good. You know what you're talking about. It's B parallel to C. And so B parallel to C, and what's the name of 10 and 12? Oh. Corresponding angles, so it's the corresponding angle converse. Okay, I think we're getting there. We are getting there. And we have some others to deal with. We are getting in the home stretch here, so that's good. And we have this picture here. Before we even start doing these, I want to label them. Not label them, but I want to mark them as we go. So angle 2 is congruent to angle 6. I want to mark this in as being congruent. I'm going to try to mark this in as being congruent. There we go. Ah, no, it's not. It's being a stinker. That's the geometric term for not doing what I want it to do. It's being a stinker. Let me see. I'm going to put it right over here Copy, and we'll put it on a blank one so that I can do this here. There we go. So it's easier to mark as we go. So we said, what was the first one? 2 and 6. So I want to mark 2 and 6 on here. I'm going to put in with one thing. Angle 2 is congruent to angle 6. So angle 2 is congruent to angle 6. So as we're looking at those, which two lines are parallel? You have to use two letters to name it. What do you think? AB and DC. So as we bounce back to that, we would say that AB is parallel, AB and DC. I'm just going to do this one. This one's AB is parallel to CD. Yes, I have a lot more marked on here, but just so we can see, this is the 2 and 6 one. AB is parallel to CD. Notice I've got the line symbols above, just to remind you that if you're saying parallel lines, you should have them, and then the parallel. And they are what kind of angles? What do you think? Alternate interior. Actually, all these are going to have the same reason. Alternate interior angles all over the place. We're just trying to identify which lines. So angle 1 and angle 5, I've got them marked with two blue lines. Angle 1 congruent to angle 5. So if you ignore the whole rest of it and you're thinking angle 1 and angle 5, which two lines are congruent, are parallel? And so for that, you're going to kind of want to ignore the middle line. If we could some way ignore the middle line. So angle 1 congruent to angle 5 would tell us, I'll just say, you can use your fingers. You can either show me this way across for the top and the bottom one, or this way to show me the two sides. Okay, so, so you're showing me the two sides or the top and bottom. So if we have 1 and 5, that's going to be, I want you to show me, is it going to be those or or this way? Okay, all right, I'm seeing more people go this way. Good. So it's the side ones, AD and BC. AD and BC are parallel because they're alternate interior. How about 8 and 4? And you can do the same thing. Show me, is it the AB and DC, or is it AD and CB? 8 and 4. I'm only seeing one person put in your input. So you're either going this one or this way. I want to see what you're thinking. Okay, wow, I think you're about split on that. So 8 and 4, that's these two. Okay, it's the AD and the BC on that one. So it's because it's still alternate interior angles, but 8 and 4. So this one, because this is your transversal. You want to identify what your transversal is, and then it's transversing from AD to BC. So those are the parallel lines. And then finally 3 and 7. Got those marked with 4 in purple. And so this is my transversal. So it's the top and bottom ones. AB parallel to CD. And so what I'm going to ask you to do is I'm going to ask you to hold on to that homework that was that's actually not due today because it's Thursday. We're going to be going over that homework tomorrow. So make sure that you have it ready, and then we'll be able to ask any questions that you might have on that. And we will sign off for right now. I think, where is it? Oh, no. How am I not recording the whole time? Sometimes it hides. It has to be. It's on the bottom?
It's the other one. The purple thing. There's there's two tabs open. I think one of them is the Mimeo Studio microphone.
When can people retake the test?
You had it open just now.
Where?
That's what